So what I said was session 2, we're going to be talking about REPL, which is an acronym standing for Read, Evaluate, Print, and Loop. It's a fancy way of saying that it's an interactive shell or environment by which we might give commands. It can process those commands and then give us a response and repeat the process, which is what we've been doing so far. We wrote code and we got responses for that code. And there's an online environment by which we can actually execute this code, REPL IT, and that's what we've been using, and that's where we store all our exercises. So I do hope that you've all made your REPL accounts. You should have access to the REPL IT link. I'll make sure to send it in the chat real quick, just to make sure that we all have it. Yeah. We have a big collection of all the exercises. You won't be able to write in them directly. I'm going to show you how you can make your own copy of it and work in it on your own. Let's just put it in the chat real quick. All right. So you should at the very least be able to see this. It's all public. And I'm going to briefly in our slides talk about the interface of this website and how you're expected to navigate these exercises. So the REPL interface that you see consists of 3 components: the actual area by which we write code, the interface, the console, which is an area that we can directly type JavaScript code and have it be immediately evaluated. And this is called Node. Node is the name of the all-in-one JavaScript interpreter. Traditionally, JavaScript has only been able to be run directly in a web browser. But Node is its standalone thing that doesn't have to exist in a web browser. And that kind of changed the landscape by which JavaScript plays a role in web development and beyond. So it's, let's see, we have a message here. Unable to fetch replies, please try again. That's because I don't have the folder for it. Okay. Let's see what's wrong with this. I'll try sending you the individual exercises I wish you to try, because it says they're public, anyone can see them. So I'm just gonna show the first one, convert to hours. We're not gonna do this right now. I still wanna go over the slides first. But, convert to hours. We did a variation of this yesterday. This is a simpler version that we're going to have you work on independently, and it shouldn't take longer than 5 or so minutes to do. I'm just going to send you the link to this to see if you're able to access it. All right. So as it says here, at the very top of the page, you'll see a big run button, and that will execute all the code that is written here on the left in the index.js file. If you want to run individual lines of code, regardless of the contents of this interface in the left, you will be able to write it directly in the Node console. There's additionally another tab called the shell. And if you're at all familiar with the terminal, it is a general purpose place where you can run a variety of commands that can pertain to creating new files or listing the files that you have present, navigating around them, and even executing JavaScript code additionally. So the shell is much more powerful than the console. But since we're predominantly working with JavaScript, you're not likely going to be using the shell all that much. But it is something you will need to be familiar with eventually. So you can run REPLs in other programming languages from the shell. Not that that's what we'll be doing. And as they say here, the acronym I earlier referred to, REPL stands for Read, Evaluate, Print, and Loop. because I can give it a command, it reads it, then it processes it, shows us the result, and then waits to receive another thing for us to tell it to do. All right. So the basics of JavaScript as demonstrated through REPL, you should be familiar with most of these already, as we've gone over them in the first session. But comments are lines that are not interpreted by the interpreter. It doesn't actually get read as code. It's purely for us to read and to make it easier to understand the meaning of the code. So you can have a single line with 2 forward slashes. If you want to have a comment that takes multiple lines because maybe you want to write a paragraph describing this, you would use what's called a multi-line comment, which is made using a forward slash and an asterisk. These asterisks in the middle are not necessary. It's just a common practice, but it's not necessary whatsoever. To end the comment, you must have an asterisk followed by a forward slash again. You can also use these as a single line comment if you would like to, but most people tend to use the former. As we mentioned, the var keyword for declaring variables is it's deprecated. No one uses them anymore, but you will find them in existing code bases, so be familiar with them, but try to avoid using them. So we do have let or const to make variables, and know the difference. Let makes a variable that can be reassigned. No, I'm very particular about not saying just changed, because I can always modify an existing variable by, let's say, if I had a number like let x equals 2, I can say increment x by 1. Actually, no, that's not a good example. That would be a mutation because I fundamentally changed the value. But if I were to take an array and add something to it, that would not be considered a mutation. So that would be okay for a constant. But if I had a number and I wanted to change it, it would be a different story. That would not be. I can show an example to make that distinction a little bit more clear, very briefly. And I'll do that in the console here. As you see, I just click that tab and it takes me to the console. Okay, from here, I can say, const x equals 1. And if I tried to increment that constant, it would complain. It would say, you can't do that. But if I had a constant y equals an array 1, 2, 3, it wouldn't let me reassign it. So I couldn't say y equals a different array 1, 2, 3, 4. That wouldn't be okay because I'm saying ignore what was already in y, make this new thing. You can't do that. But I can say take the existing array and add 4 to it. That's fine. It works just fine. So that's the restriction of const, is that you can't reassign it, make me say equals a whole new thing. But I can call built-in methods on that existing thing. So just to be very clear on that. And a console.log will display the output back to you. When you use the console, since it's supposed to print whatever the response is of what you just did, it will always return the output back to you. But console.log can be used if you wanted to say print something after every line in the function, which is something, because when you don't have a function, it has to return exactly one thing. When I give a single command on the console, it will return one thing before giving me the opportunity to give it more input. So console.log is useful for showing to the log, logging to the console, multiple things, not just the one response that the whole thing would have had. And we've seen that yesterday when we tried to print multiple values and it only gave me the last one. So that's the significance of console.log to display output. All right. And we've also seen multiple ways that we can declare functions. There's the function keyword and there are the fat arrow functions, both of which are equally valid. As far as we're concerned, you can use either one and they will do the exact same thing. So at this point, it's just a matter of preference. I think the first one's a little bit clearer. It's a lot easier to see that it is a function. But the latter one, I won't hold it against you if you prefer that for this time being. There are legitimate reasons to use one over another, but it's a little complicated and won't really be relevant in this course. So you just use whichever you prefer for this time. All right. Now we're going to talk about formatting and clean code. And we did talk about this a little bit when we regarded naming variables, but we should go in a little more depth on this. There is a particular standard by which we can format our code. Just solving the coding problem isn't enough. As a developer, you'll be submitting projects that will be reviewed by instructors. You'll be pair programming with others. You'll be submitting code against existing code bases. And it's important that your code looks clean and readable to other developers. And especially when it's not just you reading it, but when you yourself look at this code and a few months later, you should be able to recall what you're doing. And when you're working with large code bases with hundreds of lines of code, it's not always going to be obvious. You won't remember exactly what you were doing. And the comments and proper naming of the things can make it a lot easier to parse. So one thing you can do to make code, good format is to give the variables meaningful names. So if I have a variable that represents a person, like we had an earlier example of an object employee that has a name, a salary, instead of just saying it's an object A with keys B, C, and D, you're going to see, well, what does that represent? What does it mean? I just see numbers here. So it's important that if you're in a situation where you can do that, that's great. Sometimes you'll see me use variables like I and J in for loops. That's actually a common convention, I standing for iterator. Sometimes we'll use A, B, and C for placeholder variables as well. But in most cases where there is a specific purpose to that variable, you should try to make a meaningful name for it. Additionally, there are standards for how we name variables. In JavaScript, we use a thing called camel case, which means that the first letter is lowercase, and all subsequent words which comprise that variable name must be capitalized. So if I wanted to name a variable hello world, hello would be lowercase, and the W in world would be uppercase. And there would be no space. Obviously, you can't have space in a variable, but we don't use underscores, we don't use dashes or any kind of delimiter other than a capitalization of the next word. And lastly is proper indentation and spacing. You could imagine that if all the code was left aligned, it would be very difficult to see how far into the code we have progressed. And spacing should be consistent just to make it easier to read. All right, so that's the extent that we had for session 2 in our slides. Predominantly, we're going to be focused on the exercises themselves. But I actually did want to briefly talk about mutation. But before I do that, does anyone have any questions on what constitutes good code or regarding the interface of REPL?
For variables and what you just went over, uh, how do we determine or um, does it make a difference where in the code that you define your variable?
Yes, it does. In JavaScript, variables have something called hoisting. And what that means is that if I make a variable here, let's say on line 10, and on this line on line 6, I want to refer to that same variable. In most languages, we would just say that variable hasn't been declared yet, and it would throw an error. But in JavaScript, what it does is it moves the declaration to the very beginning, but it just leaves it as undefined. And it will remain undefined up until this line. So I can show an example of that and the significance of when you refer to variables and consequently where they're referred to. So let me just go back and go into an empty null place. Give me a second. Okay. Then go to session examples, and I can make an example REPL. All right, so that's a little bit slow, but here we are. So the question is where we define variables, how does it affect things? The order in which variables are declared. And I'm just going to be a little bit specific here to say the order in which variables are declared relative to which they are actually referred to. That does change things. If I refer to a variable after it has been declared, then I'll be able to access the value that has been attributed to it. But if I refer to it after a modification to that variable, then naturally it's not going to be the same value I expected. So let's say here I want to, okay, if it will run that is, let, I'm going to call it X because it doesn't really represent anything in particular. And I'm going to let it be the string hello. Cool. But before I even refer to X, I'm going to say, console.log X. So you're going to wonder, what is the expected behavior of this? See, I haven't really made X yet. So you would think that it would throw an error saying that variable doesn't exist. But if I run it, actually, yeah, it does throw an error saying that it doesn't exist yet. But typically what I would expect to see is it would effectively look like this. It would declare X up here and then make the assignment down here. So I give this a run, and I should just see undefined because I haven't given X a value at this time. So here it says undefined, and then it proceeds, and it shouldn't have returned hello. That's really just a consequence of how REPL has been declared in this environment. It returned the last thing that was assigned. But you can see that here it returned undefined first, and that's this console.log at play. It's because I made the variable, but I didn't give it a value. The value was given on the third line. And at least in this online environment, it is the case. And the rules vary in different versions of Node and different JavaScript interpreters, but you'll find that usually the declaration will be moved up. If I were to refer to X after here, like if I console.log on this fourth line, it will just say hello. And that changed the output because we console logged it after something occurred. So everything happens in a specific order. The first line is executed, then the second, then the third, then the fourth. So the order in which everything happens changes everything. It's the order of the flow. And we can attempt to control that flow and the expected behavior in which lines are executed using if statements. And we're going to be going over some examples of control flow later today. Right. So does that answer your question?
Yes, and then one additional question: does that change with the type of variable we use? So does it change between var and let and const var, or I guess?
Where the variable is placed, actually, it is true that where you can access a variable does change depending on the scope of that variable, which means where it is able to be referred to from. So if I was to create a different space, like if I was to go here and I was to want to refer to X, it will give me an error saying that X doesn't exist. And that's because this little block says I'm in a new environment. Equivalently, if I said this in a function or in anywhere else that's not directly in the same line here, it's going to complain X doesn't exist in this scope. So if I give this a run, that I'm not sure if it ran or not. Yeah, but it didn't do anything the third time. Well, I think that my camera has a built-in microphone. I was trying to use that and it doesn't seem to be working. So I opened my laptop screen here to use my built-in microphone, but unfortunately it's causing the stream to lag considerably. I'm going to try switching microphones and I want you to tell me if you can still hear me.
Okay.
All right. Can you hear me now?
Yes.
Okay, that's wonderful. All right, 1 second.
Okay, there we go. Can you still hear me?
Yes.
Okay, that's great. So now that technical difficulty is behind us, I'm going to give this a run. Okay, so it didn't run it for a third time. If I was to console log down here, I would, actually let's make a function and then call that function. And it will say X doesn't exist here. So I can say a function, myfunc, and then down here I can call myfunc. And it should complain X doesn't exist in this scope. Huh. It's not responding when I press it. Okay, I'm going to try reloading the page real quick. Oh, come on. Yeah, my laptop's not overheating. So it's a little slow right now, but I'll try to explain the situation then. The situation is that if you're in a different scope, an area where the variable was not defined, and you use let, it's going to complain that it's not available in that scope. But using var, it is brought to the very beginning of the block, which is defined by those curly braces. So it should be able to be accessed within subsequent functions. And you can learn more about variable scope. I had a link for it. I just can't seem to access it at this time. Oh, I got another question here. Is var the only one that is global, can be declared after being initialized as undefined, and the others let const are restricted by scope? I believe that is true. I can't 100% be sure about that. Scope in variable is actually one of the more complicated things, and that's actually the reason why we decided to stop using var entirely, is because this issue of scope is such a big problem for a lot of developers, even seasoned ones, that they thought it was worth not having in the first place. But in general, and I would have verified this if I could run it, this is ridiculous. If I get rid of this and I go run, that shouldn't work, but it does, which I find interesting. Okay, well, here's another thing. Yeah, I suppose that if it's declared here, the function is assuming that it has global access to variables, unless I make another one here. So let's say my func has a parameter x and I give it 10, and I click run. It's gonna print 10 because its local variable overrides any existing global variables. So local always takes priority over global if there's a naming conflict. But if I declare a variable here, let y equal, this is y. And here, outside of the function, I try to console log y. That won't work because this is local to the myfunc function. Yeah, y is not defined. And I think that even if I said it was var, it shouldn't work. Let's give it a run. Yeah, it wouldn't work either because it's still local to the function. So in either case, when you declare a variable within the function, it is only accessible within that function. Anything that's declared globally should be accessible, even if I use var. But the local one will always override. And of course, this y issue is still coming up because I'm trying to access a thing that no longer exists. So I have 10. And if I got rid of this, so I'm saying use the global variable x, and I click run, it works with either var or let. Yeah. So the distinction between var and let in JavaScript is something that I'll admit I don't have 100% memorized off the top of my head. I did not expect that question, but it's a question of where in the scope it is accessible from. And it's a very small, they're both used for variable declaration. Var is function scoped and let is block scoped. Okay. I see. So if within here I make a block, var is function scoped and let is block scoped. So that means here within this block, I can say let y equals hello. And here I try to console.log y. Well, maybe I shouldn't say hello twice actually, because it's a little unclear what I'm doing. So let's ignore x for the time being and say all I want to do is console log y outside of the block in which it is declared. It says y is not defined. But if I made y a variable with var and I run, then it works just fine. So yeah, that is the distinction when it's within a block. And a block is just an area defined within curly braces, but not including functions, because functions are a different scope. It's called the function scope. These are called the block scope. And the only reason, as far as I can think of, why you would use the block scope is if you want to have some variables override existing ones and explicitly have opportunities where those do not occur. And it's because of this confusion and the lack of use case for this particular thing that people stop using var altogether. Right. Great. Was there any other question? Oh, here. If we don't assign a value to a variable declared using the let keyword, it automatically has a value of undefined. Yeah, that's true. Undefined is always the default value for a variable if you don't give it a value. So if I went here and I just had var y, it's going to assume var y equals undefined, and it will return undefined as you see here. All right. My PowerPoint presentation seems to have closed. Okay, great. Well, were there any other questions regarding variable declaration? No. Okay. Any questions regarding formatting and what constitutes clean code?
I have a question. Can you give an example of the old code and the new code?
The old, you're referring to function declarations or variable declarations? Because
yeah, that slide, I believe.
Mm-hmm. So what I said is that they're both equivalent here. Oh, actually, I don't care what we call this. I could make a function, you know, hello, that takes these parameters and does a thing, and I could have it console log hello. And that's fine. Alternatively, I could have a variable, you know, and I can call it, you know, goodbye. And I want it to equal a fat arrow function that takes these parameters. In this case, that's none. I could give it a parameter just for demonstration's sake. This takes a parameter y, this takes a parameter y, and that's what it would look like. And I could have multiple parameters like so. I'm not going to use any parameter here though. And here I could say I want to console.log goodbye. And here I could say I want to, and the order does matter, by the way. So if I said I want to write goodbye first and then hello, I would expect it to print goodbye and then hello to the screen. So I can click run, goodbye, then it prints hello. And you see that it doesn't matter which one you use. These are both equivalent. So which one you choose to use is a matter of preference here. I personally like the first one. The second one is considered newer, and some JavaScript purists will insist upon it just because it's newer. There are some benefits. We're going to learn about structures beyond objects in the future, and there is a particular notion of variables belonging to functions through certain structures and being able to implicitly have those set which the ES6 notation will actually do for you. And I'm not really going to talk about that yet because we haven't discussed these objects at this time, so it wouldn't really make sense to talk about the differences. But as far as we're concerned, they are equivalent. Generally, I would say pick one and stick to it. That is a generalization. There will be exceptions to that rule. But if you have every other functions this, and some of them are using fat arrow, consistency is one of the things that I think makes good looking code. But you shouldn't follow it to a T. There will be exceptions, and you will have to be flexible with it. But try not to mix and match them arbitrarily. Was that example sufficient, or was there something else you had in mind?
That made sense.
Mm-hmm.
Thank you.
All right. There was one other thing I wanted to touch on briefly, and I did talk about this before, and it's the concept of mutation. Yeah, and we've been exposed to a variety of different kinds of methods in JavaScript, such as to uppercase, to lowercase, round, floor, seal, push, pop. And there's two main types of methods, the mutating method and the non-mutating method. And when I say mutate, I mean to change. So when I run, let's look at an example that isn't mutating here. When I have a variable, my var, and I have it set equal to hello world, we know that to uppercase will take each character and make it its uppercase equivalent. So this will be capital H, capital E. If it was already uppercase, it stays uppercase. If it's a space or some other character that can't be made uppercase, it will remain as so. But when it does this, it returns the result of all of these characters in uppercase. So I can console log it and see the result. And it should be hello world in all uppercase. But on this fourth line, when I say print the contents of my var, I'll see that the variable itself hasn't changed. It's still hello world. Here, I take the results, which I have seen, and I assign it to the variable. And now that changed the variable. So let's just look at that. I want to ignore the second half for the time being. I click run. And I can see that it prints hello world. That's what we, in all caps. But then I say print the variable that stored this original thing. That hasn't changed. It still says hello world exactly as it was. Now I'm saying assign this, the first result that we saw, and make that the value of our variable. And now it's in uppercase. So this method is called non-mutating because by calling it, it doesn't implicitly change the variable on which it is called. The mutating method is not like that. Here I have an array 431, and I can print the array and I'll see 431. Then I push the array. And in doing so, regardless of whether I console log this or not, I would see that this would happen behind the scenes. 431 would become 4315. That's what push does. It adds a new element to the end of an array. And here I can console log it and I will see that. So this doesn't necessarily return 4315. In fact, it returns the new length of the array. That's just the behavior of push in JavaScript. So if I give this a run, I'll see from our first console log that it is in fact 431. I push 5 to the array, and instead of returning the results of what that would be, it just tells me the length of the array. But behind the scenes, without even doing the return itself, it did it implicitly. It mutated the thing that it was called upon immediately, and it became 4315, as I can see on line 12. So that's the difference between a mutating method and a non-mutating method. One forces you whenever you want to see it, it makes the change, and the other one shows you what the change would be, and you have the option of making that change as opposed to just looking at it. Right. So that's mutation. And I think this is an important thing to keep in mind because this messes up a lot of people when they're using JavaScript methods. They will try to make a change and they'll say, if I said I want to make my array equals my array dot push 5, you would do that and you might think this is going to make my array from 431 to 4315 based on what you've seen here. This is how you would make my var all uppercase. So following that logic, this would make sense as the way that we add an element to the end of an array. But this is not what that does. This would in fact just change the array to the number 4 because that's what the array has become after adding an element to it. So it's important that we keep that in mind lest we make mistakes like this. All right. We have a list of various methods which you are going to take advantage of. We can find big lists of JavaScript methods and refer to them on JavaScript docs. Yeah, I told you that Mozilla, the Mozilla Foundation, has an excellent list of JavaScript methods and definitions. So you can look up documentation here. Alternatively, you can just look on W3 Schools or other trustworthy websites. If I just looked up a general question, like I can say JavaScript, how to make uppercase, you'll find that somebody will, actually the first result is the to uppercase method on W3 Schools. So again, Google is your best friend in this situation. And it even shows you related methods like tip. If you wanted to make it lowercase, you can use to lowercase. So that's how you can look up methods that might be helpful to you. In case, because I don't expect you to remember all of them, because there are a lot of methods in JavaScript. And the behavior of them, like does it return something? Is it mutating or non-mutating? You can find that when you look up the documentation, its expected behavior. See, this says it returns hello world, but it doesn't change string itself. And therefore, you would have to say string equals this result in order to change it. Right. So that is mutation. Now I want to talk about how you can fork a repository, a REPL, so that you can actually use it locally. Now, I sent a link earlier in the chat. Oh, there's another question here. If const was used instead of let, would .push5 still add 5 to the array? Yes, it would, because we didn't say we want to use a different array. We just modified the existing array. Since we didn't change the value itself, the value is this is an array, then it would still be valid for a constant. If we don't assign a value to a variable declared using the let keyword, it automatically has a value. Yes, that's true. All right. Was there any questions regarding mutation? Sorry, I should have asked that first. I'll say that again. Is there any questions about mutation in JavaScript? Nope. All right. The REPL I sent at 4:06 a little earlier on the convert to hours problem, were you able to actually access it? It should look like this when you load it. You shouldn't be able to write or change to it, but you should be able to see it. All right. Can someone just verify in the chat that they're able to access this window?
Yes.
Okay, great. So going back, if I go back here to my, there should be a button to fork. If I can just remember, I go to my REPLs. I go to Bootcamp Prep. Yeah. When I go to a particular problem, let's say convert to hours, there will be the option to fork it in the little, you click the 3 dots in the right corner of, and there's a fork button that you can click. And in doing so, you're able to bring it to your own, to your own account. If you have multiple accounts, you can select your account that you wish to bring it into and then press confirm. And in doing so, you'll make a copy of it with a different name or the same name if you're in a different account. And this is one that you own and are able to access. And it's it's an exact copy of the existing one. And the benefit of this is that you can all make different changes without modifying the same one that I'm looking at here. So you can all work on it independently. Yeah, you should be able to do that. I just want to verify that that is in fact the case. Right. Let me just look at the chat real quick. Okay, great. Was anyone able to fork the REPL? No?
Yes.
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 Yeah.
Okay.
Yep.
Okay, great. So now that you have it, we can look at the 2 hours REPL, and we actually. Oh, I'll send the link again. So in this particular problem, all we have to do is take a function called 2 hours, which takes a number of minutes and returns the equivalent number of hours. So 45 minutes is 3/4 of an hour, or 75 minutes is 1 1/4 hours. And it returns this as a floating point number, which means a decimal point. All right. So we did this yesterday with the convert to hours and minutes. That was a more complex version of this. So we should be able to do this in about, I say, 6 minutes at 4:50. It's actually a good time for a break as well. So how about I give us a good 15 minutes and we can meet up at 5 o'clock. And in that time, you can ponder this question and try to figure out how you would solve it. And at index.js, you're able to write your code here. All you have to do is remember that you're operating on minutes and you have to use the return keyword to get what you want out of it. And I would strongly suggest that you make tests to verify these results are in fact our expected outputs, like we talked about yesterday. All right. So this question shouldn't take longer than 5 minutes to do, and I will see you at 5 o'clock. Run this. All right, great. I did see in the chat that Tom Preet may be coming to join today's session. I was expecting him tomorrow, so I don't know if that was a typo on his part. He hasn't responded to clarify. If he will be joining today, that's great. I guess that means we'll just postpone some of the extra exercises for the next session. Otherwise, why don't we just continue until that time? So the problem of 2 hours is very much similar to the one we already did, 2 hours and minutes, except we don't have to extract the minutes component. We just find the amount in minutes directly as a fraction representation of hours. So I could simply return the number of minutes divided by 60, and let's give this a run and see if that passes our tests. So imagine if I had 60 minutes, 60 over 60 is 1 hour. If I had 45, 45 over 60 should be 0.75. So that is why we're dividing by 60, because there are 60 minutes in an hour. So give this a run. The last test didn't pass. Why is that? Ah, yes, because that's a rounding error. See, if I take 125 and divide by 60, it's actually 2.083333, not 2.083. So this actually requires some rounding. And if I'm not mistaken, we learned about there's several ways we can actually solve this. One thing is we know that we want 3 decimal places of precision at the very least. So I can multiply it by 100. 100 times minutes. And then I can say I want to divide by 60 times 100. Give that a run. No, that still didn't work. But there is one thing I can do, is I can divide by 60. And actually, I want to see the result of this explicitly, so I can see why it's not working. And this is 100 times larger than the value we expect to work with. So here we have 208.33, where we expect 2083. So we are getting the value here. We actually want 4 digits of precision, 2.08, 2.083, that's 4 significant digits. So I can multiply it by 1,000, and then I can floor it. So I can say math dot, well, actually, what you really want is round, because you want to round up or down accordingly. Yes. That needs to be like this. So it's, you got to match the brackets. So this refers to the top component divided by 60 and the round, and then divide by 1,000. because I multiplied it by 1,000 initially. Remember, the reason I have to do that to move the decimal point is because the round operation only works on rounding to the nearest integer, not rounding with a specific precision in mind. So now I'm getting 2.083, which is the expected output. Great. And now all of our tests pass. That doesn't mean it's perfect. We could be a little more creative and make some more tests if we wanted to be very certain that this is working correctly. You know that 0 is going to give you 0. We know that 60 is going to give us 1. Yeah, and all our tests pass. There are alternative ways to solve this. You might have found that all of your tests passed and you wrote the code differently. As we discussed earlier, there was another way we could have done this. One is we have the .toFixed approach. So if I actually look here, unfortunately they don't have a search bar. Oh, there it is. If I look for toFixed, I'll learn about number.prototype.toFixed, which allows you to get the number of significant digits as a string, but I want it as a number that I can actually work on. So here I can say I want to number cast, which means convert it from a string into a number. That's what casting is, converting from one type to another. I want to cast minutes divided by 60. And I do have to place that whole thing in parentheses, otherwise it will just try to apply the .toFixed method on the last number. So on this whole thing being treated as one number, .toFixed, and I care about 3 decimal places after the dot, after the period. So that's why I'm going to try 3. I give this a run, and all of my tests pass. So see, there's multiple ways this problem can be solved. And that's why I like this problem in particular, is that it exemplifies the fact that there might not just be one way to solve a problem, and you will find this consistently as you are thinking critically about problems. Now, some solutions might be better than others. You could argue that having to make it as a string and then convert it into a number might be complex or make the code slower. That the first approach, even though it might look a little more complicated, might be faster. And that depends on how JavaScript is actually doing this behind the scenes. All right. So now that we have the convert to hours problem done, or do we have any questions pertaining to this problem and the solution that was posed? Oh, I don't hear any questions. Okay, great. So the next problem we have here is called mortgage payment. It is another exercise that uses types. And you'll see in the name, it says types or types and loops or control flow. And that tells you what things that we have learned so far that you will need to solve this problem. Although there might be alternative ways to solve it, the efficient solution that we're looking for utilizes exactly those. So I'm going to paste this into the chat, mortgage payment types. And I hope you're all able to access it. So let's go over the problem real quick. The mortgage payment problem is that you should write a function called mortgage payment that takes 2 arguments, the first of which is an initial investment on a home, presumably, and a return percentage as a fraction out of 100, as a fraction out of 1, sorry. And that percentage represents the annual return on your mortgage payment that you're going to get back. So if you had $100,000 down with a 5% annual return, that would be $5,000 payment. Right. So are there any questions about this problem before we get to it? Again, make sure that you fork the problem and work on it locally. You won't be able to work on the version that is hosted here under cpadmin because you don't have permission to. And if you all tried to, you would all see each other's changes and it would be a mess. All right. why don't we take 5 minutes to work on this problem, and then we'll come back. All right? It's been 5 minutes since we began working on this problem. I'm actually going to start putting up a timer from now on, so you can see the time remaining, and I'll leave the screen sharing up. So let's look at this mortgage payment problem. Given a certain annual percentage rate and an initial investment, know what the annual return percentage would be. So here you can see we have $100,000 and 5%, and the result is 5,000. Now 5,000 is 5% of 100,000. Similarly, 1,275 is 0.085, which is 8.5% of 15,000. And I can verify that 0.085 times 15,000 is in fact 1,275. So it would seem that the solution is to multiply the amount invested with the annual interest rate as a fraction out of 1. So I can simply return the amount invested times the annual interest. And I give this a run, and you'll see that the tests have passed. Now, I want to clarify that the difficulty of the exercises will increase as we progress. So are there any questions regarding the mortgage payment problem here? No? All right. If there's no questions, then we can move on to an issue that now utilizes types and loops, the Spacex countdown. If I can just find it real quick. Let's see here, Spacex countdown. I'll make sure to send it in the chat. Additionally, I should erase these changes so that the solution's not just sitting there. Oh, if it loads, that is. So the Spacex countdown problem is one where we write a function that takes in an integer as seconds and prints how many seconds there are until liftoff. And once there are 0 seconds left, have it return liftoff. So it starts with the number of seconds that are provided, and it decreases until we have 0. Then says the string liftoff. That's what's returned. It's not printing it, it's returning it. So keep in mind, you'll need to be familiar with loops, either a while loop or a for loop. We've discussed them earlier. And if you want, you can see examples explaining them in the slides. And you can also find documentation online on for loops, either from the Mozilla Foundation or W3 Schools, among others. So this is console output, so you will need to use the console log function. I'll give us a good, let's see. I'll give us a good 5 minutes to do this one. Are there any questions before we begin?
It wants us to output even the green text there, not just the liftoff after the set time. Is that correct?
It wants you to print out these strings to the screen. These are just comments that it's provided. This is what it's expected to actually print to the screen. Each of these individually, this extra quote is a typo here, so ignore that.
Okay.
And this is returned, not printed. All right. So we can start it. This is not what I was looking for. Okay, this looks like it will work just fine. 5 minutes. All right, starting now. Great. I'm going to pause the recording, and I will see you in 5 minutes. All right, so going to the Spacex countdown problem. We go to index.js to write our code. Okay. Do you guys feel that 5 minutes was enough time for this problem, or do you feel that it was a little bit time pressed and should have been longer? I'd like to know for future exercises.
I can get the text to display, but as far as having it actually wait 1 second, I'm still working on that part.
Oh, actually, the instructions don't say that it needs to wait 1 second after each run. It just says for 0 seconds and have it return liftoff. So that is a reasonable assumption that it would pause for a second and then continue. And there actually is something in JavaScript that does that. The problems are definitely getting more difficult than they used to be. So first, we can act on the assumption that we don't have to wait called timeout, which can allow it to wait a period of time before continuing. So that's an interesting question. I think it's worth bringing it up. So I will solve under that assumption as well. All right, so let's go back to the, if I bring this down. Yeah, it can allow you to wait. So here I'm going to, and you see this one is using a fat arrow function. Again, they use them more or less interchangeably, and you will see a variation in existing code bases. So first, we're going to want to create a for loop to go from this number up until and including 0. So I can say for let I equals 0, which means we're starting a counter from 0. Oh, actually, no. We don't want to start from 0. We want to start from the seconds count. So if there were 5 seconds, it would start from 5. Then we want to say on the condition that I is greater than or equal to 0, I is going to decrease by 1 after each iteration. So you could have said I equals I minus 1, or I minus equals 1, or I minus minus. To verify that this is working correctly, why don't we just print the value of I at each point? So I can console.log I. Great. So now we can run countdown real quick with 5 seconds initially. I click run. And it goes from 5 to 0. Okay, good. But I don't just want it to say 5, 4, 3, 2, 1, 0. I want it to say there are this number of seconds left until liftoff. So I can use a template string, or I could use a regular string and concatenate them with the plus operation. And I can say there are I number of seconds left until liftoff. Then at the very end here, I can return liftoff. So now this is not going to wait 1 second between each iteration, but do notice that the instructions actually never told us to do that. But I will do it anyways, just to see how we would actually go about doing that. So let's give this a run. It says there are 5, 4, 3, 2, 1, 0, and then it says liftoff. And it, again, that's because consoles return the last thing they see. So if I were to go down here and say console.log hi, or make an assignment, I would expect it to actually not show us liftoff. So if I do this, you'll see that liftoff doesn't return to the screen. See, it just says hi. And that's because we never console logged liftoff, we just returned it. So if I wanted to make sure that that actually shows to the console, and it wasn't necessarily the last thing that occurred, I would console.log the call of the function itself, which is going to return liftoff. So when you think of return, you can think of replacing this thing that it is returning with that thing itself. So it's like I just drag and drop this into this console log area. So I click run, and I see that it actually shows up. Great. All right, so now let's see how we can actually wait 1 second. In JavaScript, there is a method called setTimeout, which can be used to wait for a specified number of milliseconds, where there are 1,000 milliseconds in a second. Oh, not mortgage payment. So let's go here in the console, and let's say I wanted to use setTimeout, and then I give it a function or a thing to run, and then a number of seconds. So I can go here and say I have a function that just says hello, but it's going to wait a few seconds. It's going to wait 1 second before it does so. Oh, I need to enclose it. Oh, I did. That's interesting. Set timeout, you give it a function and the number of periods over which it should wait. I guess that wouldn't work in the console directly, but I would, because it expects an immediate response. But if I did that here, it would work just fine. So I guess here what I could do is, instead of just console logging it directly, I can say set timeout and then run this. So set timeout. And actually, looking at here, you notice that this function doesn't have a name. This is an example of the anonymous function we had earlier, a function that doesn't have a name because I don't intend to reuse it. Yeah, and the same thing works here with our fat arrow functions. Typically for anonymous functions, you'll see a lot of people prefer to use fat arrow functions because they think it's a lot cleaner, but it's entirely a matter of preference. So I could say I have a function that runs the following. There are this many number of seconds remaining after 1 second has passed. So here I can say wait for 1 second or 1,000 milliseconds as is. I can give this a run. Interesting. Okay, so it waits for the entire thing to finish evaluating, and then it runs, which is not right. And that's also not the expected behavior in any timeout. If I were to go into, say, in any website, they have their own console where you can evaluate the variables that exist within it. And in this context, I could say set timeout, do something like console.log hello. And I can say wait 1 second to do this. And it waited 1 second and then it said hello. So that is the expected behavior, but it doesn't seem to be working on their website for some reason. To clarify that if you did this in a front-end environment like I just did here, it would work. And if I were to put this in a loop, like let's say I say for let I equals 0, or I equals 5, I is greater than equal to 0, I decreases by 1, then I can say I want to console.log I want to run this set timeout. Set timeout console.log. Let's print I, which is the number this time. We close it off, and after 1 second, it continues. All right, that looks good. I close the for loop. I will admit I am not entirely certain why it's operating this way, but set timeout is what's used to wait for a period of time. Yeah, that was not a requirement of this problem though, so I didn't have that prepared. I'm just thinking about why this is the case. Another issue with JavaScript I do want to clarify is its behavior will actually be different in different browsers because different browsers have different JavaScript interpreters. So what works in one, see, it says the alert function here will not work in Internet Explorer. And Safari, which is the browser I'm using, is actually not compliant with many things on the internet. So to answer your question, you would pause using set timeout, but this particular implementation does not work on my browser, and I'm not entirely sure why. But the generic solution was to just return the amount. All right. So moving forward, we will use more than 5 minutes. We will use 10 minutes to solve the problems, unless the problem is much more difficult, and therefore we will give it more than 10 minutes naturally. This question, next one, is called Fizzbuzz. It is a problem that is purely in control flow, which means we'll finally be using if and else. So if I can find control flow in here, Fizzbuzz. Here you are. I'm just going to copy that link. And I'm actually going to delete this for the next cohort. All right, the Fizzbuzz problem. This is actually an extremely common problem. You are almost guaranteed to see this when looking for a job. I've seen it several times myself. It's not that it's a difficult problem. In fact, it's generally considered a simple problem. It's just that there are countless ways that you could approach it. So seeing how you solve it tells me an awful lot about how you as a programmer think. So the Fizzbuzz problem, or Fizzbuzz test, is an interview question designed to help filter out a great number of job candidates. The text of the programming assignment is along the lines of this. Write a program that prints an object with a number of keys. The key is the number, and the value is the number fizz, buzz, fizzbuzz, or the value itself, or the key itself, I mean to say. But for multiples of 3, instead of having the number, you will have fizz. For multiples of 5, you will have buzz. And for multiples of both 3 and 5, you will have fizzbuzz. So 1, which is a multiple of neither 1, 3, nor both, is 1. 2 is 2. 3 will be fizz. And it repeats. And yes, this assignment is for a beginner. For multiples of 3, you can assign the keys value. I can give us more time if we're feeling uncertain about it, and I'll make sure to go over this problem in detail. For numbers which are multiples of both 3 and 5, or 15, because anything that's a multiple of both 3 and 5 is the multiple of the product, which is 3 times 5, or 15. assign the keys value to equal Fizzbuzz. To just be very clear, my console has stopped compiling. You need to, in order to solve this problem, you are expected to use if statements. You have if, the condition on which the following should be executed. So here you have a Boolean or something that evaluates a Boolean. Here you have the body of what is to run on this condition being met. Then you can say, if that wasn't the case, else if, and then another condition which can be evaluated. And then it has a body. And then lastly, you can have an else statement if none of the above were met. And that's the basics of control flow to refresh your memory. So you can say, if the value is 1, then do this. If the value is 2, then do that, and so on and so forth. All right. So you could say, if the value is divisible by 3. And that's actually an interesting question of how can you check if something is divisible by a number? And I would tell you to look into the existing operators that we have. We have addition, subtraction, division, but we have something called modulus, which returns the remainder of a division operation. So if I said I have 1 mod 5, that's going to be 1 remainder 5, because it's 1 divided by 5. 2 mod 5 is going to be 2. 3 mod 5 is going to be 3. 5 mod 5 is 0, because 5 goes into 5 perfectly. 6 mod 5 is 1, because it goes in once and then has a remainder of 1. So you can see how it alternates. If I was to actually go along the line, I have 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, and it just keeps repeating as the input value here increments by 1. So actually, let me show you in a loop real quick. Let I equals 0, I is less than 100, and I could say I plus plus. I just want a console.log I mod, and I can pick a number like 10, for example, and give this a run, and you'll see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it restarts. And the fact of the matter is, every instance where it is 0 is 10 digits away from the last one, starting from 0. Therefore, every 10th digit is going to be denoted as 0. And that's a good way to check if a number is divisible by 10. So now that we have that knowledge of how the modulus operator works and a common use case for it, we should be able to find problems that are divisible by 3, divisible by 5, or divisible by 15. All right. So do we have any questions pertaining to the modulus operator and how it works before we continue with this? I just want to be very clear. I know we went over it yesterday, but I wanted to be very clear about that because you will require that to solve this problem. All right. So I'm going to give us, I think 15 minutes should be sufficient for this problem. Again, I don't want you guys to feel bad if you don't get it the first time. These problems are not supposed to be easy. Like we said, it is going to take some practice. And as you get more familiar with the operators and their use cases, these problems will become easier. So I want you to give it your best effort in the next 15 minutes. So let me just reset the timer here. Oh, did I not give the link? I'm sorry. Okay. All right, you should be able to see it here. All right. So remember, one thing I would make sure that you focus in this particular order, where you first try to generate this order, 1, 2, fizz, 4, buzz, fizz. Don't even worry about building the object first. Your first priority should be generating this sequence. Once you're able to do that, then try to make the object. That's the way I would go about this. All right. So I'm going to start the timer at 15 minutes, and I will see you then. So you can watch them at your own pace and review the solutions to make sure you understand them. There are a variety of methods which you might prove helpful in JavaScript in solving this problem. So I would hope that you look them up online. So a simple thing you could do is how to build an object in JavaScript. So if you're stuck on it and saying, I don't know the method I need, you could go on Google and say how to build an object in JavaScript. And do make sure you specify the language you wish to utilize. Otherwise, you might end up with a different example. So how can you build an object, but maybe be a little more specific about the problem with indices for the keys, you know, an object with indices. And you should find that there are indexed collections, but that's not what we're looking for. JavaScript has something called an assign thing. So object.assign in JavaScript. It takes a little bit of searching. Like I said, a majority of problem solving is going to be a lot of researching. Target and source. Yes. So there are a couple of ways we could do this. Yeah, I'm going to be posting the recordings soon, as soon as I extract them. The exact distribution method hasn't been properly determined yet. I know that we have a YouTube account. I'm going to try to put it there. If not, Slack is probably a perfectly valid place to place it. Was not able to loop in output, but not able to get them in key value pairs. That's fine. Honestly, building the key value pairs, I wouldn't place too much emphasis on that. The main focus of the Fizzbuzz program in most applications is just generating the Fizzbuzz sequence itself. So why don't we first just focus on doing that? So firstly, we know we want to go from 1 to this number, 100, all the way down there. So that means we're going to have a for loop to generate the sequence. So I can say for let I equals 1, because we're starting at 1 instead of 0. I is less than or equal to the number, because it's going from 1 up to and including 100. I plus plus, because it's increasing by 1 every single time. And within here, we're going to start needing a control flow, because we're not just going to print the number. We're going to say if the number is divisible by 3, so to represent that, I can say I mod 3 equals 0. And what that means is, remember when I showed you earlier the representation of mod, let's say I is 1. Then that gives me 1 mod 3. How many times does 1 go into 3? Well, 0 times, but I have a remainder of 1. So that means the result is going to be 1. 2 mod 3. Well, that's, 2 divided by 3 is 2 over 3. So I have a remainder of 2. 3 mod 3. Well, 3 divided by 3 is 1, and I have no remainder, so that's 0. So the way the pattern works is whenever the remainder is 0, that means that we have a number, a division, without any remainder. And by definition, that's what it means to be a multiple of a number. You went in perfectly, 5, 10, 15, 20. Those numbers have no remainders after them. They're perfect multiples of the number in question. In this case, we're looking at 3. So 3, 6, 9, 12, and including 0, because 0 mod 3 is also going to work. But we're starting from 1, so that's not going to be in here. So if I mod 3 is 0, that's the same as saying if it's a multiple of 3. And you might want to make a comment here, saying fizz if multiple of 3. Just to make it easier for you to read. So that's a good example of where you might want to use comments. You also do have to be careful about commenting too much. And it's more of an art form than a science. You get a good feeling of what commenting is considered. Over commenting, where you see comments on every other line, and it actually makes it more difficult to proceed through the code. And then there's under commenting, where you don't really know what's going on and you really wish there was a comment there to explain it to you. So if I mod 3 is 0, which means it's a multiple of 3, then we want to see fizz. So else, which means on the condition that it is not a multiple of 3, on a condition if it's a multiple of 5, I mod 5 equals 0. You can console.log buzz. But there's actually a subtle problem here. Let's say I wanted to go at the end of this and I say else, if it's a multiple of 15, say Fizzbuzz. Here's the thing. All multiples of 15 are also multiples of 3 and 5, because 3, 6, 9, 12, 15. 3 goes into 15 perfectly. 5, 10, 15. 5 goes into 15 perfectly. So every time I have a multiple of 15 here, it will just execute this first if statement and not proceed. Okay, we've noticed a problem with our control sequence. So in actuality, we need to check if something is a multiple of 15 before we check if it's a multiple of 3 or 5. Okay. So I can say if I is a multiple of 15, then, equals 0. That's important. Console.log Fizzbuzz. And on the condition that isn't met, and you do need to say else if, because if you don't say else here, it will evaluate this, and then it will also try to evaluate the next line. If I say else if the one before it was evaluated, it ignores everything else in the else if chain. So that is important. Otherwise, every time you see Fizzbuzz, you're also going to see fizz. So you've got to change this into an else if. Alternatively, you could say is a multiple of 3 and a multiple of 5, which is the same thing. But some people might find that easier to read. If it's a multiple of 3 and I is a multiple of 5. So there's two different ways we could have represented that. Then it does this. If it's just a multiple of 3 and therefore not a multiple of 5 in this instance, this will run. But if this fails and it is a multiple of 5, then it'll just say buzz. Lastly, if it's not a multiple of 15 and it's not a multiple of 3 and it's not a multiple of 5, then it fits the I'm just going to return the number anyways kind of condition. So I can console log the number itself. Great. So this is not actually giving us the whole object key value pairing. It's just giving us the sequence. So let's say I run this with, well, let's go with like actually 30 or 20 is a good number. That way I can get to at least the 15 here. But I'll make sure to go through it step by step to show you what the logic is for each iteration of the for loop to make it very clear why I put it in the specific order I did. So let's give this a run. And you can see, I should probably clear the console first to make it easier to read and then give this a run. So we have 1, 2, fizz, because that's a multiple of 3, 4, 5 is buzz, because 5 is a multiple of 5, 6 is a multiple of 3, because 3, 6 goes in twice, 7, 8, 9 is 3 times 3 is going to give you 9, 10, 5 times 2 gives you 10, 11 doesn't go into 3, 5, or 15, 12, that goes into 3, 3, 6, 9, 12 goes in 4 times, 13, 14, 15. It's a multiple of both, so it says Fizzbuzz. Okay, that works. And you can and it repeats, and you can see that it is in fact matching up to 30 inclusive, which is also a multiple of, you know, both 5 and 3, because that's 15 times 2. All right, so this is working, as we can see. So let's pretend that we're going to go through this one line at a time. I is 1. Okay, we're looking here. I'm actually going to get rid of this comment here. If I is 1, that means is 1 divisible by 3? No, it's not. Is 1 divisible by 5? No, it's not. So neither of these are true, and both of them have to be true for this to pass. So it ignores it and it looks at its else statement, because that's what happens on the failure of meeting an if condition. It evaluates its else condition only on that condition. If the if statement was evaluated, it ignores everything in its else, and that includes the entire else chain. So this didn't work, so we're going to look at the next one. Is 1 divisible by 3? No, it isn't. Is 1 divisible by 5? No, it isn't. So this doesn't happen either. It goes to the last else and it just prints the number, which is why we see 1. Now we move on to 2, and the same process happens. 2 is not divisible by both 3 and 5. It's not divisible by just 3, and it's not divisible by just 5. So it prints the number. Now we get to Fizz. We get to number 3. It's going to say, is it divisible by 3? Yes, it is. And is it also divisible by 5? No, it isn't. So this statement does not pass. It's true and false. And as we learned earlier, that's going to result in just false. So it looks at its else statement. Is 3 divisible by 3? It is. So it console logs Fizz. And because this statement was matched, it ignores everything else in its else chain. And therefore, it just goes to the next instance of the for loop, incrementing I by 1. So now we're at I is 4, and it repeats step by step. And how about we move on to the case where we're at 15, because that's the next significant one. We're going to say, is I divisible by 3? Yes, it is, because it's 15. And is it also divisible by 5? Yes, it is. I could have 3 instances of 5 to get 15. So then it gives me Fizzbuzz, and it ignores everything else. Now, if we had this Fizzbuzz, let's say at the end or after this first fizz or this buzz, it wouldn't work. And let's pretend that that was the case. Like if I got rid of this and it was just starting with this condition fizz, it would say, okay, is 15 divisible by 3? Yes, it is. It is divisible by 3. So it just prints fizz and then it ignores everything else. That also means ignoring the condition where I check if it's divisible by 15. So you can't have a condition that precludes another one I wish to evaluate before that other condition. So Fizzbuzz has to occur first, because any time where either of these are true is all such cases where this would be true, and therefore this would be ignored. So the order in which you make your if and else if statements really does matter. And that's one of the important things to take away from Fizzbuzz. All right, so now that we've generated our sequence, we still have to make the key value pairing in an object. And building an object is something that we haven't explicitly talked about. There are a lot of ways it can be done. One thing we can do is there's something in JavaScript called a mapping. You know, I don't want us to worry too much about this. I mean, I'm going to show it to you. I don't expect you to have been able to build the key value pairing object. I just wanted you to really fixate on the idea of trying to get this control pattern in the right way. That was the main focus of Fizzbuzz, but we can give this a try. In JavaScript, there's something called object spreading. So here I can assign a target to a spread of sources. And what that really means is it's as if I passed everything in the array as if they were individual arguments. That's something a little more advanced, and I don't think we really need to talk about that. This was in the collection of exercises provided to us for beginners, but I do feel like that's not really something you should worry about too much at this time. But one thing we could do is we could have an object, like let my object, for something to call it, be an empty object. And let's say I want to add something to that object. So this is a good time where we can take advantage of Google, which is something you'll always be doing, no matter how long you've been doing this for. Add key value pair to object. in JavaScript. Yep. The way it works is you can use dot notation. Here you have an existing object with a key value pairing, and you can say, refer to the object dot the name of the key equals then the value. Or you can use the square bracket. There's two different ways you can do it here. Okay, there could be a lot more methods. We don't really need to worry about that as long as we have identified at least one valid such method. So we can go in here, and instead of console logging it, we want to add it to the object. So I can take every instance of console log, and I can say my object indexed at I is going to equal this thing that I would have otherwise returned. And at the very end of the function, I'm going to return that object. All right. So now let's give this a run. And you can see we do in fact have a index paired to a value, but it's creating them as strings. We don't want that. That's interesting. Why did it make them strings? Well, there is one thing we can do. We can refer to every instance and make sure that it is in fact a number. Or alternatively, we can use the dot notation I mentioned earlier. Because one thing I noticed in this Stack Overflow is that in their square bracket notation, the key is a string. That's interesting. So what if I say my object dot I? How would that work? See, it takes I literally as the name instead of evaluating it as a variable. Therefore, you need to use this kind of bracket notation. And number casting doesn't seem to solve it either. There's a lot of various solutions to it, some are more complex than others. I don't want to talk about spreading. I know I briefly mentioned it, but it is something that's a little beyond the scope of this course, so I'm not going to talk about spreading right now. But the general idea that you can add to an existing object is something that's useful to know. We're going to leave it as a string because the process of converting all of them might be a bit tedious. All right. So that's the Fizzbuzz problem. I know that might be a lot to take in, but we are having this recorded, so you're free to rewatch it. Do we have any questions about this problem? All right. So just to reiterate the main points, if you have multiple things that are going to be evaluated, you always, and those conditions conflict with each other, you have to be careful about the order in which you place them. So for example, if I have a condition A and a condition B that must both be met simultaneously, you can't check for each of those individually beforehand, because in all instances where both A and B are true, A is true individually, and so is B true individually, by definition. So that's a problem in logic that you will learn in discrete mathematics and philosophy. You'll often learn about these problems of looking at variables and their assignments of true and false, and the order in which we must assign them. So I just want to keep it simple, but there will be other such cases where the order in which you do your control flow really does matter.
I've got a question.
Yes.
If you were to write a test to compare your result to the object in the example output, is there an easy way to compare objects?
That's a good question, actually. In a lot of languages, comparing objects is no simple matter. Some of them will just compare the fact that they're both objects of the same length. Some of them will check, because in order to compare objects, you also need to compare all the elements within the object. So like, let's look at a greater problem. And the answer is it's different in every language. So let's say I wanted to compare two arrays, 1, 2, 3. Does that equal this other array 1, 2, 3? And it should say no, they're not, because they're different arrays. Like they have the same values inside of them, but they're still different. If I make an array 1, 2, 3, and I make another array y equals 1, 2, 3, these are two different collections, even though they have the exact same state. So I could say x dot push, 5, and the change occurred in x, but it didn't occur in y because they're different. They're different sets that happen to have the same collection. So if I wanted to compare an existing object with, an object to compare with, and I just say, are they equal? It will say, no, they're not, because they're not literally referring to the same object. What I need to do is I need to scan every single element inside of it and say, is this equal? And that's a very tedious thing to do. For arrays, I can just iterate over it, and I could make my own little function like, is it equal? So I could say a function is equal, and it takes two arrays. And I could say, and I could say for let I equal 0, I is less than the length of A. And actually, there's one thing you could do. First of all, if the length of the arrays or objects are not equal, you already know that they're not equal, right? So immediately you could say, if A dot length does not equal B dot length, you can say return false. They're not equal, right? But otherwise, you could have a for loop to compare each value one at a time to make sure they are equal. So I could say for let I equal 0, I is less than A dot length, I plus plus. And I could say if at any point I see that the value of A at the index I does not equal the value at B at index I, then I can return false. They're not equal. I found an instance where it's not the same. And if I find even just one of them, I know it's not the same. 1, 2, 3, and 1, 2, 4. Doesn't matter that the first two are the same. The last ones aren't, and therefore they're not equal. So I return false. And if I manage to go through every single one of them in that array, and I didn't find one, then I know that I can return true. Yeah, return true. And I can close this. So now I can say is equal on my x and my y. And, well, it should have returned true. Oh, the reason why is because I added something to x. So I can say y dot push 5. And now they both have the same values, even though they are different arrays. So now I can say is equal xy, and I get true. So the way that I would compare, and it's the same idea for objects, except instead of looping over indices, you're looping over the values. And we can do that with our for in arrays instead of the for of variant.
That makes sense. Thanks.
Yep. Yeah, that was a very good question. And it's not immediately obvious because when you look at it, you just say they are equal, they have the same values, but the operation on one does not equal an operation on the other necessarily. And when it comes to arrays or objects, that distinction matters. All right, so that's Fizzbuzz. I know that is a difficult question. I didn't mean to say that it's an easy question when someone asked if it's an easy question, because it's definitely one that a lot of people will struggle with, but it is a common question that you will see as an interview question for most programming jobs. And that's why I found it really important that we go over this. All right, it has been 2 hours and 30 minutes in total. Why don't we take a 10-minute break and I will see you all at 35. All right. Recording. All right. So do we have any more questions about Fizzbuzz before we continue? Any more uncertainty about how control flow works? Or because if you want a demonstration of if else and how that works, I just want to clarify one more time. If I have a condition A and I have a condition B such that they must both be met, then whenever A is met and not B is met, like if it's the case that you have A but you don't have B, and I'm looking at this first, like if I try to evaluate this first, but I had this condition where both A and B are true, it will look at this and say, is A true? Yes. Okay, cool, then it runs. Unless I explicitly say A and not B, then it wouldn't conflict with this. So I could have said A and not B, and then check A and, or not A and B, and then I can check for A and B, right? That can be the order in which I check it. However, that requires me to be very explicit about all of them, and that requires a lot more comparisons that are necessary. It would be smarter to compare A and B first, because in any case where both A and B are true, and I'm only checking A, and I'm ignoring the other one, I'm only checking B. Imagine if A and B were both true, and I check for A first. A would be evaluated. If A and B were both true, and I'm only checking B first, B would be evaluated. In either such case, we would never reach the condition of A and B if it was after both of these. And to be clear, I'm using A and B as placeholders for the Boolean representations that would be held there, such as whether or not a number is divisible by 3 or 5 or any number for that matter. So this holds to any Boolean expression. All right, so that's Fizzbuzz. Let's take a look at another problem. Caffeine control. That one utilizes both control flow and types. So let's find caffeine control. Copy a link. And I'll send this in the chat shortly. This one also utilizes control flow, but I feel that the problem is much simpler in that the order doesn't involve any conflicts. So the problem is this. Every weekday, you drink caffeine to get ready in the morning. On Monday, you need 800 milligrams of caffeine to wake up. On Tuesday, you need 600. Wednesday and Thursday, you need 400. And on the Fridays, you need 900 because you're staying up late. But you can only buy energy drinks in packets of 150 milligrams. So if I say I need 20 milligrams, tough luck, I have to buy a 150 milligram energy drink to get that 20 milligrams. So you can only buy in multiples of 150. So we need to write a method that takes in the day as a string, which is represented by M for Monday, T for Tuesday, W for Wednesday, R for Thursday, and F for Friday, and then returns the minimum number of caffeine drinks you'll need to buy. So here it says on Monday, we need 6 drinks. And look at it this way. On Monday, we need 800 milligrams of caffeine, and each drink has 150 milligrams of caffeine. So 150 times 6, 150 times 6 is 900 milligrams of caffeine. So that is enough. But let's say we bought 5 cups instead. That'd be 750. That's less than 800, so that's not going to work. So we can bring this up to 6 and we meet it. So it's the smallest number of drinks that meets the minimum requirement of caffeine for the day. Even if it goes over, that's fine, but you can't go under the amount. All right. Are there any questions about what this problem is asking or the expectations of the problem? No? All right. So we have 20 minutes left. So we can solve this problem in 10 minutes. I think that's good. And then we'll have 10 minutes to solve it. All right, so I'm going to start the timer. All right, and let's get right into it because it looks like we have 8 minutes. We can, if we run out of time, we can briefly return to this problem's solution in the next session. All right, so there's the obvious solution of using the if-else kind of chain to solve this problem, and that's the one I'm gonna start with here. There's about 3 ways I can think of doing this. I'm gonna start with the easy way to do it, not necessarily the way I would usually do it, but you're gonna see some redundancies, which I imagine you would want to avoid. That's actually a general thing, and when it comes to coding, is the amount of code you reuse, you can reduce, is generally a good thing to do. So I can say if the day equals m, and you want to make sure it equals it strictly. Then I want to return, well, I know that I need, actually this is a good place where I want to keep track of the amount of caffeine I need. So one thing I can do here is I can say let caffeine, it's I before E, E before I. Let caffeine needed. I'm just going to declare it. I'm not going to set its value here. And if it's M, then I want to say that caffeine needed is set to 800 milligrams, or just 800. Else, if the day is equal to Tuesday, which is T, our caffeine needed is going to be 600 milligrams. All right. So if that wasn't met either, now I can check for Wednesday or Thursday. So if it's either Wednesday or Thursday, on either such case, it's going to be 400 milligrams. So I can say else if day equals W, or day equals R, which represents Thursday. Then I can return caffeine needed equals 400. And on the last condition that it's Friday, it will be 900 milligrams. At this time, we've kind of exceeded all of our options. But if it was another day, like let's say I gave it like Z, how should I handle that edge case? We didn't actually talk about appropriate behavior. So in that case, it's really up to your discretion. Else if day equals 900, instead of setting it with an else statement, one thing we could do is we could give caffeine needed a default value of, let's say, 0, right? So that way, if I got a day like Z, I can say I don't need any energy drinks that day. I have 0 caffeine needed, instead of having else set it to 0, because if none of these are met, then none of these will have been run, and it just stays at 0. So that's an alternative to having the else set it equal to 0. So here I can say, oh, my bad, day is not 900. Day is F for Friday. And then we set caffeine needed to 900. All right. And now that we know the amount of caffeine needed and we've considered it for all the possible days, we have to think about the problem of how many drinks do we actually need on that day. So in the case of Monday, we established the fact that 6 is the smallest number that multiplied by 150 is greater than 800. So let's see, if I take 800 and I want to say what multiple gets to 150. So 150 times what is 800? Well, now we want to isolate what that number is. So it's just dividing on both sides of the equation, and we end up with 800 over 150. We need 5 and a little bit. We need 5 drinks and 1/3 of a drink to get 800 milligrams of caffeine. But you can't order 1/3 of a drink, so you need 6. So what we really need to do is we need to always round up. So even if it's 5 and like 1/10 of a drink, or percentage very small, we still need to always get one up. So just like we are already familiar with math.round to round up or round down, and math.floor to round down, there's also math.ceil, which rounds up. Alternatively, you could have implemented math.ceil using floor by adding one and then flooring it, which would have brought it down. All right, so we can take this, seal it, which will bring it up to 6, and that's the value we would return. So here I can say I want to return math.ceil, which means round up whatever I have next. And it even says here, returns the smallest integer greater than or equal to its numeric argument. Great. So I want to take the amount of caffeine that I need. So caffeine needed divided by 150. Great. So now let's write some tests real quick. How much time do we have left? We got 2 minutes. All right. We're not going to discuss any alternative solutions, but there are many. So we have both of these. All right, give this a run. And you can see that both conditions have been satisfied. They're both true. So it works for these 2 tests. If we had more time, I would have liked to develop more tests to test all these other cases. But the order in which I actually ran these doesn't matter because none of these conditions conflict with the others. Unless there was a condition like where it's both W and R, but that doesn't make sense, right? That can't be a thing. All right. Do we have any questions? I'm willing to go over a little bit if you want, if you have a longer question. No questions about this last problem? All right, I'll make sure to post the recordings later tonight as soon as I edit them and get rid of any unnecessary or technical difficulties. All right, I will see you all on Thursday. Remember, Tom Preet, our lead instructor, is going to be coming in to answer any questions about the application process, code Platoon itself, and certain expectations pertaining to the course. And I'll also make sure to answer any additional questions you might have about this problem and Fizzbuzz if there are any lingering questions remaining. All right, so I'll see you all on Thursday.